In this video, I'm going to be talking about integration by parts. It's a method we use to integrate when we have a product in our integrand. And so the first thing I want to talk about is what motivates this formula. Where do we get this formula from? And it actually comes from the product rule. So consider the derivative, d by dx, of u times v. We know by the product rule that that's du dx v plus dv dx u. Cool. Now I'm going to do something that's questionable. I'm going to multiply both sides by dx. So if I multiply both sides by dx, this dx will cancel, and this dx will cancel. And so what I'm left with is d of uv equals v du plus u dv. Okay? So next, what I can do is I can integrate both sides. So if I take the integral of both sides here, I get that the integral of duv is just uv, in the same way that the integral of dx is just x. And then I have the integral of v du plus the integral of u dv. Okay. Next, what I can do is subtract the integral of v du from both sides and rearrange to get the integral of u dv equals uv minus the integral of v du. And this formula here is the exact formula I have up here for integration by parts. So this is why the integration by parts formula kind of works. It's not necessarily a proof of it, but a demonstration of it. Okay, so next I want to talk about an acronym that helps us pick u. So when we are picking u, we should consider this mnemonic because it'll tell us what most of the time will work as our u. So I stands for inverse trig, L stands for logarithmic, A stands for algebraic, so that's like polynomials, and T stands for trig, and E stands for exponential. So we should go in this order when picking our u in IBP. So we'll start off with this first example here, the integral of x sine x dx. So following ILATE, I pick algebraic to be my u, because I have an algebraic function and a trig function. So I pick the algebraic because it comes first in the acronym. So I will let u equal x. And I will let dv equal sine x dx. Sine x dx. We just pick dv to be whatever is left along with our differential dx. So letting u be x, we have that du by dx is equal to 1. This tells me that du is equal to dx. Okay? Now having dv equal to sine x dx, I can integrate both sides. So integrating this will give me that v equals negative cosine x. And we can omit the constant of integration for the purpose of doing integration by parts. So next what we do, let me go ahead and move this over here, is we're going to apply the formula. So my formula for integration by parts is that the integral of u dv, which this is my u, this is my dv, so this is my integral, is uv minus the integral of v du. Okay, so that tells me that my integral here, I'll call it I, is equal to u, which we just said was x, times v, which we said was negative cosine x, minus the integral of v, which is negative cosine x, du, which in this case is dx. So my integral I is equal to negative x cosine of x plus the integral of cosine x dx. Well, the integral of cosine x is just sine x, so this becomes negative x cosine x plus sine x plus c. And this is the integral of x sine x. Okay? So next we're going to move on to a slightly more complex example. So the integral of e to the x cosine x dx. So remember I late. We're going to pick, we have an exponential and we have a trig function. So we're going to pick our trig to be our u, and we're going to pick our exponential to be our dv. So we're going to let u equal cosine of x. So du will equal negative sine x dx. And we're going to let dv equal e to the x dx. And so that tells us that integrating both sides, v is equal to e to the x, because the integral of e to the x is e to the x. Now, what I'm going to do is I'm going to let our original integral, again, I'm going to name it. I'm going to call this guy I. Okay. Now, I is equal to uv minus the integral of v du. That's just the integration by parts formula. So this tells me that I is equal to u times v, so u is cosine x, v is e to the x, minus the integral of v is e to the x, du was negative sine x dx. Okay, so I is equal to e to the x cosine of x plus, bringing this negative outside, the integral of e to the x sine x dx. Okay, interesting. So this, I encounter the same problem as I would with this, where I can't integrate it using u sub, so I do have to do another integration by parts. In this case, I'm going to use different variables because we've already used up u and v. So I will let s equal sine x, then ds will equal cosine x dx, and I will let dt equal e to the x dx. Integrating both sides, we get that t is equal to e to the x. Okay, so applying integration by parts again, I have that I is equal to e to the x cosine x plus, so it's going to be st, so e to the x sine x. Right. So what I'm saying is that this guy here is equal to st minus the integral of t ds. So this is my st here. Now minus the integral of t, which is e to the x. ds is cosine x dx. Okay. Now this is very interesting, because remember that the integral e to the x cosine x dx was my original integral up here, and I named that I. So I actually have I is equal to e to the x cosine x plus e to the x sine x minus I. Okay, well, why don't I just go ahead and add I to both sides? So I'll go ahead and add I to both sides. Now I have that 2i is equal to e to the x cosine x plus e to the x sine x. I'll go ahead and add my constant of integration now. Interesting. So now I can just divide both sides by 2, and that will solve for I, which was my original integral, e to the x cosine x dx. And I'll show you what I mean. Dividing both sides by 2, I, which is equal to the integral of e to the x cosine of x dx, is equal to 1/2 e to the x cosine x plus 1/2 e to the x sine x plus c. And that is the solution to this integral. So sometimes when we're doing integration by parts, we may have to do multiple steps. We may have to apply integration by parts multiple times in order to get our solution. And in some cases, we get another copy of the integral that we're trying to find. Now, if that happens, we can just move it over to the other side and divide by the excess, like I did here. Okay, so moving on, we have the integral of ln x dx. Okay, this one's interesting because it doesn't look like a product. It doesn't look like, x sine x or e to the x cosine x where there's an obvious product. but we can still apply the method of IBP to figure out what this integral is. So in ILATE, my logarithm comes before anything else other than inverse trig, and I don't have any inverse trig here, so I just pick my logarithm to be my u. So I will let u equal ln of x. Then du by dx will equal 1 over x. That is, du equals 1 over x times dx. Okay? Now, the rest of it is going to be my dv. So I'm going to let dv equal dx. Integrating both sides, I get that v is equal to x. Okay? Now, again, I'll name my integral I. And I is going to be equal to the integration by parts formula, uv minus the integral of v du. So I is going to be, let's see here, my u is ln x, my v is x, minus the integral of v is x, du is 1 over x dx. Okay, so this tells me that I is equal to x ln of x minus this x and this x will cancel because I have one in the numerator and one in the denominator. So I have the integral of dx, and that's just x. So this tells me that I, which is equal to the integral of ln of x dx, is x ln x minus x plus c. Okay. So we can apply the integration by parts formula when we just have something like this, something like ln x, and we can pick the function to be, we can pick just the integrand to be our u, and we can pick the differential to be our dv. Okay, and that kind of wraps up what I wanted to say about integration by parts. If you found this helpful, please consider liking and subscribing. Thanks.